Today's webinar is brought to you by Design World and TEGAM. So before we get started, I'll just mention a few housekeeping points of order here. Just a reminder that this webinar will be available at our website, designworldonline.com, after today's webinar, if you'd like to view it or reference it once again. And everyone who registered will also receive a copy of the webinar via email. Also, there is a resource widget that you can use to view the webinar slides, so you can move them around and size them to suit your preferences. Keep in mind also that we will have a Q&A session after this, so you can submit any questions you may have via the Q&A widget at the bottom there as well. And we'll do our best to get to each and every question during the Q&A portion of the webinar. Lastly, if you're on Twitter, you can tweet about the webinar using the hashtag DWWebinar. So my name is Miles Budimer. I'm a senior editor with Design World magazine, and I'll be moderating today's webinar. And a little bit about our presenter today, who is Adam Fletter. So Adam is the president of TEGAM. He holds a BSET degree from the University of Akron, as well as an MBA from Case Western Reserve University. He's been with TEGAM for 15 years, serving also as Director of Marketing and Sales, and has over 20 years of experience across a broad range of industries, including broadcast TV, airborne radar, and industrial automation. So with that, I think I will hand it over to you, Adam.
Thanks, Miles. I appreciate the introduction. I sound better than I am actually in person. So today we're going to be talking about simplifying some of the food safety tracing and recording requirements of some proposed government regulations. Haven't gone into effect yet. Talking about some ways to make that easier. I am not by any means an expert in nutrition science or even food safety in itself. At TEGAM, we make a lot of great thermometers, and because of that, we end up touching a lot of industries. One of the key ones is food safety, and so we talk with a lot of people in the industry on how they use our products. And I also keep an eye out for changes that are going on. And what we want to cover today is some of the changes that we've seen that are coming down the road that will impact food processing and food safety in the coming future. So with that, let's just look at a little bit of what we're going to talk about. The first thing is the Food Safety Modernization Act, Section 204 overview. This is not going to be in depth, but it's going to be the areas that impact the temperature measurement and food safety. We'll talk about some ways that people actually perform data collection today and some of the pros and cons of those. We'll look at some practical considerations of your facility and how you can collect data. We'll talk about what we see as the key to really enabling good data collection, and that will be talking about an app-based method for these records. And then we're going to talk about the actually new proposed rule that's coming down on calibration laboratories and how that will affect the different food safety facilities. And finally, I'll just give you some of the links and resources that I used when I was doing my research for this presentation. And mainly these will be the FSMA links. So you can read this on your own in case you're having trouble sleeping at night. These are great aids for insomnia. So with that, let's look at the FSMA Section 204 just a little bit. So the FDA announces some more three-letter acronyms. The Food Safety Modernization Act, FSMA, became law in 2011, but as is the case with many of these rules and laws, that they require some interpretation by the agency that's responsible for enforcing them, in this case the FDA. And so it has become clearer and clearer since 2011 how the FDA would like to implement some of that. Also, as we've learned to do this, there become enhancements. So Section 204 is one of those enhancements. It's titled Enhanced Tracking and Tracing of Food and Record Keeping. And this was announced in September of last year, and then was subject to a 90-day public comment period. And that concluded here just in January. So this is not in effect yet, but it is in its very near final form at this point of what will be released, and we don't know when it will be fully into effect. I'm just totally guessing that it's about a year from now, but that's subject, obviously, to the government itself. And as we all know, we don't control that. So here are some of the key concepts of Section 204. The FTL, the Food Traceability List, is one. And it came out at the beginning in the proposed rule change in September that this list would exist, and they have released now the actual list. And what's on it are things like cheeses, eggs, some fresh fruit and vegetables, fin fish, shellfish, and their derivatives. So if you make a product that incorporates some eggs, that becomes also subject to the food traceability list. So if any of these ingredients go into your final product, you're also subject to this rule when it goes into effect. Another concept in it is the critical tracking event, and these are, some key points at where the product may change hands, or it may get cooked, or it may get stored in a cold storage of some sort. Whether it's mixed into something, and then of course shipping. So it defines these events, what becomes critical to your process, and then what are the key data elements or KDEs that need to be tracked. So a lot of what is tracked on food, of course, is where did it come from, when was it produced, these types of things, so that if there is a future recall, they found that there were some contaminated eggs. They can identify which farm they came from. They know what date they were shipped and what lot code they came from. So they can say what foods incorporated these eggs. Pancake mix or whatever this might have gotten mixed into. So they know what foods to recall from the end consumers. One of the key data elements, of course, is also a kill step. And a kill step is a heating process typically. There are other means, but the most common one is a heating process where the ingredient is raised to a temperature that kills off any potential pathogen. So the kill step itself is described in more detail in the regulations. This is paragraph V.F 1.1355. Again, if you'd like to refer to the links at the end of the presentation. But one of the key takeaways from that is that you must document the kill step. So when you raise a food to a certain temperature, you need to record the temperature that it was achieved to demonstrate that you did actually complete the kill step. And they're looking for the actual temperature readings, not a checkbox on a form that says, oh, I did this, I did the kill step. Now, they like to say, I did the kill step, and it was 166.2 degrees. And they're like those records preserved for 2 years so that, again, if there's a recall somewhere down the road, they can track back through these records to see where things are done. The kill step, although is an important one, too, to document because it alleviates some of the need for tracking once that's completed. Once you've sterilized the food, effectively, it's not as critical that it be tracked. Of course, documenting that you did sterilize it is important. So in the process of doing this, what are ways that we've seen that people have used data collection to record these things? And the first is the most prevalent and common to all is the clipboard and paper. It certainly appears to be simple. It's awkward. Of course, if you have a thermometer in one hand and a pen in another hand and a clipboard in a third hand, you end up with all kinds of interesting adaptations, including things like people write things right on their glove that they're wearing, and then transfer that to a clipboard later so their glove gets covered with ink, which is nice and sanitary. When you write things down on a clipboard, the studies show that there are about 2 to 3 errors per page, and that's just writing a number down wrong or writing a number down and not being able to read it later. It is open to fraud, unfortunately, in the production environment. Things have to get done on time, and sometimes some of this training that goes on, some of the activities that go on, you end up having to put the results down later in the shift, and so sometimes that gets subject to just being made up on the spot. It takes too long. Anything that takes too long gets pushed to the side. It can be a source of food contamination. Clipboards and paper, great places to store contaminants. Then you have to store the paper. It's not real-time information. The FDA in the regulations preferring digital records. And today in the world of COVID protocols and COVID concerns, the FDA can't necessarily come and visit you to look at your file cabinet. They would like to be able to look at this online in real time. That provides a faster response, and it obviously is easier, it's cheaper, and it eliminates the trouble. And if you're in some sort of facility quarantine, well, then it's hard to visit your facility anyway. So then another method is to automate the clipboard. So you take the clipboard, people still write data down on it, and they hand it over to someone else who then types it into a computer. And this is very common as well. The interesting problem is that it actually increases the error rate, because now you've got somebody looking at a clipboard and typing it into a computer, and that there's errors associated with that. Additional labor, it's inefficient, requires 2 people to do it, or at least one person doing it twice. More opportunities for fraud. And again, the information's not real time. You end up with the information maybe at the end of a shift. So then what some people resort to make this easier is really a custom system integration. And this can be a significant investment. It's minimum of $10,000. We've seen projects that cost $1 million. And when you're investing that much, you want to make sure that it's right. So projects can fail for a number of reasons. However, that it might be the best solution. We've seen people build very interestingly integrated systems that tie the purchasing system into their product reception at the loading dock, and tracks it all the way through their facility until it ships out to their customer. So the custom solution can be very good if you've done the investigation and research up front to know what you need. It also becomes less flexible because now once you've built this system, you're going to use it, and you can't change things as easily, or to change things is expensive. But often security is a concern. It enables unique forms of real-time data, and it can minimize errors. But the purpose of the webinar today is really to talk about an app-based collection method that we've developed. And it becomes a universal solution. It allows multiple data points to be captured, even across multiple different types of software. It'll enable immediate real-time access. It works with the mobile device for ease of use and worker familiarity, minimizes the training. It does not require IT support or a costly integration. And it will work with your existing software, so that you can, even multiple software, so that you don't have to spend time implementing it. You can start using it immediately. We'll talk about how that occurs a little bit later in the presentation. But when you are devising a means of collecting data and automating that you still have to do the basics. What do you capture? This comes out of your hazard analysis and the critical control points that you've identified. Custody transfers are, of course, time of capturing data when when someone delivers a product to your dock, you want to know that it was delivered in a condition that you're willing to accept, in incoming inspection and also outgoing inspection. Then your storage facility, was your storage facility under control? And of course, as we discussed already, kill steps are important to document. How you do that, the environment that you're operating in, some of the concerns would be how rigorous, how much contaminants are in the area. Some processing facilities can see a lot of different types of material that can contaminate a thermometer. We need to be able to clean the thermometer. It needs to be designed for that purpose. Ours are. We've been working in this environment for several decades and are fairly comfortable with it. The cold storage, sometimes your thermometer needs to operate in a deep freeze, and it's interesting when you look at the way thermometers do work. There are considerations. Some thermometers do not adapt to cold very well and give you erroneous readings for many minutes until they've adapted to the cold of the environment they're in. Rough handling, and we've seen thermometers that look like somebody ran over them with a forklift, and they want to know if they can be repaired. So there are a lot of considerations there, and even the method of data collection. Sometimes the person needs to go out and do a survey and collect a number of points and bring it back to a central terminal if that's how they've designed their system. Other times people can take the mobile device with them and use that right in situ. So these are all considerations to what needs to be done. So what we think is the key to really successful data collection with temperatures is we want to connect temperature readings to a quality system without ever rekeying data or changing software. And we literally mean that ever, because if you require an operator to do this, it will get done less. You want to make doing the job right the easiest path, and then it gets done, and getting done accurately. So let's look how we can actually do that. The first we start with, we have an app here on the right, and this is the iOS version. We start with the basic methodology of copy and paste. Many people are familiar with this. They use their phone. It provides great flexibility. It's compatible with a wide range of software because it's using the operating system tools that are in existence. It's familiar already to the operator, so training is minimized. And it leverages the touchscreen technology of a phone or a tablet. And it enables you to do some process monitoring as well. So if you look at the display on the right, you see the temperature display. You could touch the temperature display. If you're using this on a tablet, you could have both the software that you're using to record these readings in open at the same time. You touch the temperature, you paste it right into the other field that you wish to record data in. And you can do the same thing with the statistics that have been captured by the thermometer, the min, max, the average. All of those numbers are copy and pasteable. Now, some other workflows require you to do data logging. You may not be able to, as we said, take the mobile device with you, just the thermometer. You may go out and record 4 or 5 readings and wish to bring them back to a central terminal. And unfortunately, the physical arrangement of the plant may not be in the same order of the software fields that need to be entered. You want to record those out of order. So you go collect 4 or 5 readings. You pick the 5th one, you paste it in the first field. You can do that with this data logging screen because you can simply pick the timestamp and data and temperature line and copy that, paste that again into the area. Or if you're copying this into some other, whether it's a spreadsheet or some other documentation, you can actually copy all of the data list right at the top by touching the header of the table, and you'll get the full data list. And that includes a timestamp because now you are out on a floor. You may be out there for 15 minutes collecting this data, and the time that it collected is important. So that comes with it. That's preserved as part of this data logging methodology. But a third way that this can also be done, and this is all built into the app that we provide with our thermometer, is the keyboard extension. Keyboard extensions were developed if you've ever used like emojis and different icons in texting. That comes through a keyboard extension. We developed a keyboard extension that has the real-time thermometer data built right into it. So you can see in real time on the channel buttons what is happening with the temperature. When the reading has stabilized and the operator's ready to make the measurement, all they have to do is touch that button. So they don't actually have to interface with the thermometer at all. They see the reading here on the keyboard extension. It's a large button, so it's compatible with gloves. You can touch that. It puts it in the field that you've highlighted. You touch the next field. You touch the next button. You simply one touch your way through your form. No typing, no data entry, and there's no software that has to change because all of the software is set up to work with the keyboard. So the interface is already built into the mobile device that you're using. We had a few other auxiliary keys for different work processes, so tab, carriage return, backspace, that kind of thing is built into it as well if necessary. The other thing that the keyboard extension works with, of course, is really any other type of software that you have on your phone. So if you're using a spreadsheet, you want to do some ad hoc process development, you just want to record some things, store it in the spreadsheet, you can do that. The keyboard extension enables that. And beyond that type of documentation, you can also actually do some graphing and troubleshooting of a process. You're developing a new recipe. You can put you can put the product that you're testing in the oven, and you can see how long it takes to come up to temperature and optimize that process. And because it's a phone, you can do all the fancy things you can do on a phone now, so you can pinch and zoom the temperature scale or the time scale, both. And of course, you can amuse your friends and amuse your colleagues with that. So another proposed change to rules involves calibration. And calibration is an important topic because when you're making a measurement with a thermometer, you want to know that the measurement you're making is accurate. It's critical. The number is what you're verifying. And if you're certifying some food is safe because it's been raised to the right temperature, you want to know that that's actually true. And so how do you know your measurement is accurate? And there are some things that could go wrong in this process. Obviously, your instrument could just be out of calibration. It is no longer adjusted correctly. It's reading wrong. And if that's the case, that your number is going to be incorrect proportionally. Probes can become damaged. Some of the probes that get used are maybe subject to physical damage depending on the application and how hard they're used, and that needs to be checked periodically. And of course, the operator is also a source of error. If the process by which they have to capture this data is a little bit too difficult, they may not wait the full amount of time for the reading to stabilize and get a good number, and you need to make that not a complicated process. But what we're going to focus on here is really how do you know the instrument and the probe are reading correctly. So a part of an FSMA proposed rule change is on laboratory accreditation, and this encompasses a larger area than just the temperature measurement. There are other measurements, and there are other, testing the food. There are many other aspects to this rule. So I'm just focusing on this one piece. Within that piece, they're recommending an international standard, ISO 17025 from 2017, and it is description of how you manage your calibration laboratory and trace the measurements that you make. And you can think of it as like a chain of custody for measurements. So when you make a measurement, that instrument was compared to some calibration instrument at a laboratory at some point, which was then compared to some laboratory standard to make sure that that measurement is good. And that's traced all the way actually to a national standard, in our case, NIST. So there's documentation that shows when your instrument makes a measurement, there's a paper trail all the way to a national standard level. And that's ISO 17025 describes that process of how you manage your lab to do that. What really is important for food professionals to understand is that as an organization, we have been doing that for several decades. It's important to other industries like aerospace, the semiconductor industry. So the practice is already in place for us, and we can provide that documentation with our thermometers. The issue comes up is how often does that need to be done? And that's something that is developed by an organization's own quality system. Most organizations will do that on a periodic basis of a year. We actually design our products to be a 2-year calibration interval. We guarantee them for 2 years. Some people take advantage of that and save money on calibration. And the question is, when does this go into effect? When does this new requirement? As a court case was actually decided back in January, the FDA has agreed to implement this in February of 2022. So this rule has been out for a while, and there have been some, of course, discussions of when it is a requirement. But now it looks like, again, a year from now, it will be in effect. But there are other concerns is, if you're using a thermometer and it somehow is damaged, and after 6 months, you won't know that it needs calibration for another 6 months till you send it back. There are some verification methods that you can do locally. You can do these. I've seen some people do these on a daily basis. That may or may not be necessary, but they're not hard. There are electronic calibrators that will simulate temperature, and you can check your instruments out with those. You can also use an ice bath. You can take the instrument and the probe as a combination and use typically an insulated vessel like a thermos bottle or a vacuum flask. I've seen people use a good styrofoam cup. But if you put in a quantity of crushed ice and just put in enough water to fill the spaces in between the ice and let it sit a bit, you'll get what the physicists call a triple point of water, something that balances right at 0 degrees Celsius or 32 degrees Fahrenheit. You can very easily check your thermometer with that solution, and obviously if it reads 0, you've validated that it's reading correctly, both the electronics and the probe. Some people are more belt and suspenders, and they want to do a cold temperature and a hot temperature, and another one is the boiling point of water. That's very close to a lot of cooking temperatures, so it's very convenient. But the interesting thing is the ice point of water is very consistent. But the boiling point of water does vary with your altitude and barometric pressure. So you need to know what your altitude is and correct for your boiling point. So if you're doing a boiling point of water check in Denver, it's going to be different than it is in Cleveland. Another way people can do this also is a simple instrument called a thermal well, which is basically a small heated block with a hole in it that you can put a probe in, and the heat of the block is maintained at a very static point, and then you can validate that your thermometer is reading at that. So you can do this, again, on a daily basis if you wish, a weekly basis, whatever is important to your quality procedures and according to the rigors of your facility. So with that, I'd like to just show you some of the links and resources if you're interested in reading more in depth. This is the Federal Register of the announcement of the additional requirements for traceability records for certain foods. as I said, the food traceability list is now published. Here's the link for that. You can actually download it and see if your foods are involved. The proposed rule text, this is the actual Federal Register, the documents of it itself, if you want to read into that. And then there's laboratory accreditation, the FDA announcement of that. And then I have a link here for the news story where the laboratory accreditation being implemented in February of 2022 is. So with that, I think we're ready for any questions that might come up. Appreciate the time and the ability to present this information to you, and hope it was useful.
All right. Well, thanks, Adam, for that. What I have to say was a very informative presentation there. I certainly learned quite a bit about food safety there, I think, and I think the thing that struck me the most was that clipboard and paper portion there that you mentioned, and how prevalent that still is, I guess, as a record keeping technique.
Yes. It's we're very familiar with it, and familiarity is always the first thing we go to as people.
Yeah, interesting. All right, so as Adam mentioned, we can now begin the Q&A portion of the webinar. So just want to remind everyone out there once again that if you do have any questions for Adam, please feel free to submit them through the Q&A widget there, and we'll try to get to as many of them as we can here in the time that we have. So let me see what we have in the queue here already that we can maybe start with. Well, so there's a question here about when the proposed regulations take effect. I don't know if you answered that kind of already or not, or if there were separate pieces of it that go into effect at different times. I'm not sure what the right answer is there.
Yeah, so we mentioned two. There was a Section 204 proposed rule change, and that when that goes into effect is indeterminate at this point. There hasn't been clear guidance on that. I wouldn't expect that to be delayed much, because these are issues that have been that's been knocking around since 2011. So it's been 10 years ago, and so the public comment period is closed. So, and again, I'm just guessing, but this could probably be sometime next year. The other part of laboratory accreditation, that is more definite. Is FDA has agreed to implement that in February of 2022, as a result of some legal agreements that from some litigation that occurred. So that one link you can read, if you're interested, you can read about that. But that's a little more definite.
Okay. All right. Good. That helps clear that up, I think there. Let's see what else we have here. So this is a question about thermometers, really more specifically, but how are thermometers designed to withstand food processing environments, and can they be easily cleaned? I know you made some reference to the instrumentation, to the probes, that kind of thing. So.
Yeah, and that is an important point, because as I mentioned, the clipboard and the paper are certainly a source of contamination, and so can thermometers. Depending on the design of the thermometer, it might have really nice handy buttons, but they can be a source of where contaminants can lurk. Because we've done so much in the food safety industry, we make our keypads sealed one piece that you can just wipe off, and there's no crevices. And the whole instrument is designed with very smooth contours, so they're not cracks for food particles to hide and start to decompose. So they can be cleaned properly. So you do have to pay attention to that. The thermometer does need to be designed for that environment.
Yep. All right. The next one here. So this is looks like it's a question about training. What type of training is required for operators to be able to use the phone or tablet app?
That's obviously a key point, because when you do any kind of data collection, the operators need to be on board, and that's one of the benefits of an app is it operates with the standard we used in Apple publishes a human interface guide. That this is how we want your software to work on our phones, so that it's consistent, and we followed that in these designs. So the app itself is very intuitive. People will know how to use it really within a minute. But the other side of it, of course, is training people to use the quality management software. If they're using it today, they already know how to use it. If they've been recording data on a paper and handing that off to someone else to put in to the system, most of the training we've seen has been people on the software system that you're using to save the data. But again, that can be fairly easy, and the systems are typically designed for very basic and intuitive interfaces as well. But again, you can pick one that works, and we're not concerned, because our approach will work with whatever software you're using now.
Okay. Yeah, and as you kind of pointed out there too, it kind of builds on the fact that people are already familiar with using some of these technologies on their phones and things like that. So the learning curve is kind of flattened, I guess, right? It isn't too big of a
Yes. Yes.
Okay. All right. Let's see what
it doesn't work with a flip phone, though. So that's the.
It probably won't work with a flip phone. That's what you're saying.
Yeah.
All right. Fair enough. All right. So here's another question here. This one seems to be more specific to a specific application. It says that I have a vat that needs temperature readings every 4 hours, including during the night when an employee isn't available to take the temperature. Can your instrument take readings automatically?
Oh, that's a good question, and I didn't address that much in my presentation. But yes, one of the ways that you can store data, you can set it up into an automatic mode, and you can actually set the thermometer up by itself to do this, so separate from the app, and say I want to collect a reading every minute, let's say, and it'll just store those readings in the thermometer itself. So you can leave that as a standalone operation. Our thermometers are made with very long battery life, so the typical data collection thermometer will run like 1,000 hours on a set of 3 AA batteries. So you can monitor a process, all week long or something if you wanted to find out what's going on and automatically collect that data.
Okay, cool. So along, I guess, similar lines, this is a kind of a question of, are there any, or are there some examples that you can give of successful data collection projects?
Sure, without revealing any specific names, but we've done we did some projects where somebody was managing a grocery warehouse, and they were receiving actually ice cream. The commodity is almost irrelevant. They could be receiving finfish or shellfish, but they received some ice cream. They actually right on the purchase order, they were recording the temperature that they received the ice cream. So they tied it into their ERP system. So not just their quality management system, but even their ERP system. Said, I got this lot of ice cream at this temperature. I put it in my storage facilities. It came out of my storage facilities, and before they shipped it to their customer, they checked it again. So they had an unbroken record on the purchase ordering and the ERP system of temperature records. And that was it was just very interesting, and that was very specific to them. So they actually did a full custom integration.
Okay.
But they made that very easy, and they used a Windows 10 Toughbook tablet to make that survive the industrial environment.
Okay, cool. Yeah, that sounds interesting. All right. Here's another question we have. It says, as an OEM who provides food washing equipment where data logging already takes place for both sanitizer levels and temperatures, how can we help our customers streamline this coming rule change and be ready prior to its implementation? And one step further, integration with software such as those discussed today.
So I probably would need to know more about the specific application. I'm as an OEM who's providing a food washing equipment, I would guess that you are they're going to record those sanitizing steps as part of it, and so that might need to be put into their customers' quality data. And I would think that how that interface happens. I mean, I don't know what the type of equipment is on the OEM, but that would be, I'd certainly be open to talking about that offline.
Okay. Fair enough. So let's see. It looks like we're reaching our time limit here. So if I don't know if we have any more questions coming in, I don't see any right at the moment. So maybe we can kind of wrap things up here, or start to wrap things up. So before we do, let me just reiterate a couple of those housekeeping items that I mentioned earlier. As I mentioned before, this webinar will be available at designworldonline.com, and everyone who registered will receive a copy of the webinar by email as well. Also, if you're on Twitter, you can still tweet about this webinar using the hashtag DWWebinar. You can also connect with Design World through our various social media presence there with Facebook, LinkedIn, Twitter, YouTube as well, and also on our very own engineeringexchange.com site as well. Also, if you think of some other question that you have for Adam, you can certainly contact him as well, or send us those questions, and I'm sure Adam will be more than happy to get back to you and answer those questions for you. So that pretty much wraps things up. Just want to say thanks again thanks to Adam, certainly, for your time and your expertise here today on this very, very interesting and informative presentation. Thanks to everyone for joining us today as well, and hope you all have a good rest of the day.